We're going to practice how to find the slope of a line, either given the rise and the run, or given 2 points on the line. So first, it's important to understand that slope is just how steep a line is. If you can see my picture here, we can see that the change in the y values, because remember on the coordinate plane, this is the x-axis and this is the y. So the change in the y values would be considered the rise, and the change in the x values, this direction, would be considered the run. And so a slope of the line is the ratio of the rise over the run. Rise over the run. Now, it's fine to use rise over run when we don't have coordinates, but we actually have values. You can just write a fraction using those values, reduce if necessary. However, sometimes we have to use the slope formula, which looks like this. So we'll practice both of those ways in this video. You might see slope written as change in y over change in x, because that is what we're doing, is we're finding the difference in the y values and the difference in the x. Delta y over delta x, again, delta just means the change in, and so that is another way you might see slope. So we're going to start with a few sort of simple examples, because here we don't have to do any calculations. We're going to write the slope as m, and we're going to write the rise over the run. In the future, I won't write rise and run, but the rise is 15. So there's a change of 15 feet, and there's a run of 5 feet, and therefore that slope is 3. The feet would cancel out. 15 divided by 5 is 3, so my slope is 3. For my next question, the slope of the roof, the rise is 8 feet, the run is 20 feet. This one will not reduce to a whole number, but I can reduce both the top and the bottom by dividing by 4 to get 2/5. So the slope is 2/5. It's important to kind of do a mental check as you're finding the slope. So if a slope of the line is positive, it should point up from left to right. So as you're reading a book, if it's pointing up from left to right, that's a positive slope. A slope of 0 is going to be that horizontal line that we looked at. And remember, when we graphed a horizontal line, that was a y equals some number equation. When the slope is negative, that's when it's going to point downward from left to right. And the undefined slope is the vertical line. And again, that was when it was x equals some number. So we're going to practice finding the slope on an actual coordinate plane. So first, let's do it the same way we did last time, using that rise over run. So choose a point to begin with, and it doesn't matter which one. I'm going to choose this one. And to get to the point 3, 0, not as the crow flies, but if I had to drive a car to get from here to here, I would have to go down 2 units and to the right 3 units. So the rise is actually a negative rise because it's a fall, and the run is 3, so my slope is 2/3. Now some people don't like that, or they say, well, what if I would have started at my other one? Well, if I would have started at my other one, I would have had to go up 2, which is positive 2, and then to the left 3, and that would be negative 3. So then I would still have the exact same slope. It doesn't matter if the negative's on top or on bottom. Typically we write it on the top. Now, this way is a little cumbersome because we have to count, and counting isn't always easy, and if it's not already graphed for us, we would actually have to graph it first and then count, and that's too much work. So we're going to use the slope formula, which is essentially finding the difference in the y values over the difference in the x values. So one good thing to do as you're getting started on this is to label your points. So my first ordered pair, I'm going to call that x1 and y1, which essentially means my first x and my first y. And then I'm going to do the same thing to 3, 0. This would be my second x value and my second y value. And now to find the slope, I'm just going to replace y2 with 0, and then minus replace y1 with 2. x2, which means my second x, is 3, and x1 is 0. 0 minus 2, I'm going to keep flip change to get negative 2. 3 minus 0, oops, is not 0. 3 minus 0 is 3, and so I get the same slope of negative 2 over 3. Now again, I get a lot of people who ask the question, what if I would have labeled them differently and called this x2 and y2 and this x1 and y1? Would it matter? It wouldn't, but let's go ahead and do it. y2 would now be 2, y1 would be 0, x2 is 3. Oh, just kidding, I got confused there. x2 is 0 minus x1, which is 3. Goodness, I get confused because I have this written down here. 2 minus 0 is 2, and 0 minus 3 is negative 3. So again, we found the slope each way. We're going to do this one again the same way. So rise over run to get from one to the other. Here I would be going up, it looks like 4 units, and then to the right 2 units. So my slope would be 4 over 2, which would reduce to 2 over 1, or just 2. And now I'm going to duplicate that, finding that using the slope formula. So I'm going to call this x1, y1, and this x2, y2. So my slope would be y2 minus y1 over x2 minus x1, which gives me 4 over 2, which is 2 over 1, or 2. So notice we're getting the same thing each time. Now we're going to do this without the graph to help us out. So we're just going to use that slope formula. Again, you can continue to label those points. y2 is 2 minus y1, which is negative 1. Notice I put that in a parenthesis. It helps so that I remember that I'm subtracting a negative. And then x2 minus x1, and that gives me 3, because I keep flip change at the top, or ching ching. 7 minus 1 is 6. I reduce that to 1/2. On the bottom, the slope is y2 minus y1 over x2 minus x1. Again, on the top, I'm going to keep flip change. Negative 5 plus negative 5 is negative 10. 6 minus 4 is 2, so my slope is negative 5, or negative 5 over 1. These are a little bit different because as I find the slope here, y2 minus y1 over x2 minus x1, notice what's going to happen on the bottom of my fraction. I get a 0. So I'm not going to say that my slope is 7 over 0. I would call this undefined because you can't divide by 0. If I were to graph that, that would be a line that looks like this. This is that vertical line. On the second one, again, this is one of those special cases. y2 minus y1 over x2 minus x1. I get 0 over 3, and this is the slope of 0. And that's going to be that horizontal line if I graph it. Try these two on your own and see, then press play to see how you did. Try these two on your own, then press play to see how you did. For my first, y2 minus y1 over x2 minus x1 gives me 3 over negative 9. That would reduce to negative 1/3. So notice I moved the negative to the top. It's perfectly legal to do that. Some people would also write it as negative 1/3 like this. It's really all the same thing. For my second example, 3 minus negative 2 over 9 minus 9. On the top I get 5, on the bottom I get 0. A 0 on the bottom means an undefined slope.